Hi, I'm Crystal Carlson, and I'll be talking about the difference in gait biomechanics of walking barefoot in flip-flops, sandals, and shoes. So some background information. Thong-style flip-flops and slide-on sandals have become a very popular footwear due to their convenience, comfort, and lightweight. In an observation study of 1,000 women at a U.S. mall, 21% were wearing athletic shoes, while 43% were wearing flip-flops. In another study, it suggested that wearing shoes such as flip-flops and sandals during childhood influences arch development. Also, children that tended to go barefoot had a lower chance of being flat-footed and a higher chance of normal arches compared to kids that typically wear shoes. Ground force reaction is the force exerted by the ground on a body in contact with it. Center of pressure is the average location of where the pressure force is applied. Kinematics is the method of observing or measuring the position of joints and segments through each phase of gait. And kinetics is the method of measuring the ground reaction force at each joint and then calculating the muscle activity or soft tissue resistance present to stabilize the joint. So the purpose of the study was to identify the difference in ground reaction force, center of pressure, and lower extremity joint kinematics and kinetic variables during level walking barefoot in flip-flops, sandals, and running shoes. The flip-flops and sandals were chosen for their popularity and simple design, while the running shoes were chosen as a standard neutral running shoe. In this research study, 10 healthy males participated. Prior to participating, they confirmed that they hadn't had any injuries in their lower extremities or a history of surgeries. The participants walked down a hallway as a non-camera motion analysis system was used to collect kinematics during testing, and a timer was used to monitor and measure walking speed. Anatomical markers were attached to the iliac crest, greater trochanters, lateral and medial femoral epicondyls, lateral and medial malleoli, and head of the first and fifth metatarsals. 4 tracking markers were attached to the lateral posterior aspect of the pelvis and lateral thigh to track the segmental motions during the walking trials in order to define the joint centers for the pelvis, thigh, and feet. For the results on the ground reaction force, they found that barefoot produced the shortest stance time while shoes showed the longest stance time, loading rate at mid-stance, and the peak propulsive ground reaction force was smallest in shoes compared to the other 3 tests. Results for the center of pressure. Peak medial center of pressure was greatest in barefoot and smallest in shoes. Medial-lateral center of pressure displacement in stance phase was largest while barefoot. And lastly, barefoot had the smallest anteroposterior center of pressure displacement. And last thing we tested, the joint kinematics. Barefoot showed the smallest foot contact angle or flat foot contact angle, and shoes had the greatest contact angle. And contact angle is the angle between the foot and the ground at heel strike. And then they found that ankle dorsiflexion contact angle was smallest while going barefoot. Ankle plantar flexion range of motion from foot contact to peak plantar flexion was greatest in shoes. Peak ankle dorsiflexion in mid-stance was greatest while barefoot. Knee contact angle was greatest while barefoot, and knee flexion range of motion in stance phase was also smallest in barefoot. So in conclusion, through their findings of this study, The male participants showed that open-toed and running shoes have a lower efficiency rate than going barefoot in relation to center of pressure and ankle and knee kinematics. With that said, the need for flip-flops and sandals will continue as they are a form of protection in high fashion. As a result, this study may be helpful as it reveals the effects of open-toe and barefoot on the lower extremity mechanics.